All right. It's 9 o'clock. I think 1 minute past 9 o'clock. Let's get started. Welcome everyone this morning to the Civic Digital Twin Progress Challenge and the Future Direction Workshop. Yeah, it's great to have everybody here. And also, I know we also have lots of attendees actually joining from online through Zoom. All right. My name is Zhao Dong. I'm currently a research scientist manager and lead at the Meta Reliable Research team. Today, let me do the opening remark and welcome everybody here. So, let's get started to think about 3D digital twin, right? We all know actually, if we first look at from a single object level, since we can see the 3D digital twin will be accurately encompass the shape and the appearance of the single object. That's the first property we actually usually expect 3D digital twin to have. And you can see here, we actually compare the side by side a real physical object shoot by photo and also compare with its rendering with its 3D digital twin. One of the things side by side, the shape and appearance wise, they match very well, actually. But this was actually using a very professional SOTAR, industry SOTAR setting to create this kind of digital twin. So, but as you can see, with this kind of standard, we can already get very high accuracy for this. So the second property for digital twin, our object is not just polygon soup. It has functionality. For example, like here, right? You will see the drawer, you will see laptop. I mean, you are using every day. These all have to have this kind of functionality. So if you want to make your digital twin for the object, you also need to make sure you can recover the functionality of the object. Moving further, right? And the object in the real world, they have like weight, they have physical size, they have central mass, all this kind of physical property. And moving further, for example, if you look at the string I show here, it also has something we call the metadata, such like nutrition fact and the total calorie, all this kind of information. All these actually are the property of your physical world object. As a 3D digital twin, you should all compare all this information. So then, you can really treat your 3D digital twin as the virtual counterpart, as the real world object. And since it has very comprehensive information, it's very accurate. It can be used for like nozzle analysis, simulation, interaction, visualization, and even for decision making in nozzle applications, essentially. So that's what the ideal digital twin object we want to have. It's actually, as you can see, there's so many properties. It's actually, how can we fully recover all this property for every object surrounding us? It's actually an open challenge still. To resolve this, last year at the ECCV, we actually released very high quality, probably the highest quality currently, the object reconstruction dataset we call the digital twin catalog dataset, or DTC. As you can see, it contains a few thousand of this kind of very high quality object with millimeter level geometry accuracy and the photorealistic appearance. It's actually already available online. So that's our motivation for releasing those kind of DTC data is trying to, pair the community and work with community together to push in this kind of field forward to make sure we can really pushing forward to, create a very high quality digital twin for the object. But what if you are not only object, but you're not only handling object, you're also handling thing or word, actually, as you can see. All this kind of real world is super complicated and very, very diverse. You have so many objects combined together. In this case, it's a very more challenge. Or even, right, what happened if you will say, hey, I want to create a digital twin of my whole building. For example, this is our one of our building. Actually, you can see we are trying to just using an egocentric array glass to do the capture device. We're actually trying to recover the whole building as a digital twin. But what we just said, it has still relatively easy, let's say, because it's all static environment or static object. Our real world is dynamic, right? People have all this. You can see the lady dancing here. You can imagine my cat is walking in the floor or something like that. So even further, right? This is actually another very typical case. When we are dealing our daily life, we actually have not this kind of operation, we do not interaction with the surrounding environment. This is also very dynamic, highly dynamic case. So how can we recover this kind of digital twin for the physical world, actually? So what I'm trying to show you here, a few things, is just trying to showcase this actually is very challenging. Okay, this is still open problem. However, why we want to do all these kind of static objects, static environment, dynamic thing, all those things? Because the digital twin formed a very fundamental data representation and also support and also downstream application. For example, like the spatial and contextual AI, and also potentially for this kind of more recent people put lots of effort into robotics. And even don't need to mention the very classic AR, VR, and also, for example, if you think about all the game, all the movie, people trying to create the digital content, trying to make this kind of digital production be possible. So that's why we regard 3D digital creation is actually very fundamental and a critical problem to really unlock lots of downstream applications. All right, motivated by that, we land up an incredible speaker today to trying to share their thinking and also share the research progress. And also we are going to invoke some discussion about how to build the 3D digital twin and what is kind of challenge and what will be the future direction. This is our agenda today. As you can see, we actually have a pretty tight agenda. We have like a lots of talk lined up. Each talk length will be, a duration will be like 30 minutes. You probably can expect a few minutes in the end for the Q&A. And just be careful at the long time until 2 p.m. we are going to have a lunch break. Please come back at 2 p.m. We are going to, after the morning session, we're going to continue at the 2 p.m. for the afternoon session. At the end, I want to point out we actually prepared a discussion panel, because I think it's good to not just you hearing the talk from the speakers, right? It's great to we have this communication through the Q&A. We want to hear how you think about the future for the 3D digital twin creation. I want to thank. This is a great effort. We actually had lots of support and from our excellent organizers. I want to really show my appreciation and thanks for them, actually. Finally, I want to say, well, actually, for the discussion panel, we actually do have a Google form. If you are interested, you can just like take a picture of this and you can find the Google form link. It's a very simple form. You just like fill about a few questions you would like to discuss. At the end of before the discussion panel starts, we are going to gather the question, and also we are going to have a few domain experts from our speakers and also from our organizers to join us together in the end to discuss all these questions, essentially.